Okay, we get to move on into perceiving objects and scenes. This is usually one of my favorite talks or lectures, or it becomes a teeny, it's still kind of me lecturing, but usually it becomes a little bit more of a discussion as I ask students questions, and I'm going to leave a lot of that in there, even though it's going to be strange, and you're not here to answer me. That's really hard for me to deal with. But the other thing is, it also is the first time that we start getting into something that I think is more relatable and more psychological theories. We're gonna this neuroscience. I mean, this is the way the field is going. It's gonna dip its head in here every once in a while, but I feel like a lot of what we've done so far with what's happening in the eye, and especially with the um, lateral inhibition and how that gives us those receptive fields of the retinal ganglion cells going into the subcortical structures and into the cortex. And even as we're getting into higher level processing, I feel like we're talking about a bunch of concepts that really aren't relating to your experience in life. And I'm hoping that this is the beginning of you starting to feel like, oh, okay, this is a psychology class. That's more than just neuroscience. So I usually do this. Well, what is this? And you can think about your answer. And I sometimes get flowers. And I sometimes get guesses as to what flowers. I actually had somebody who works in, I'm not sure, I don't think it's really botany, but some more like maintenance, but he works with plants a lot, kind of jokingly say lavender, and people kind of laughed, and it's clearly, these are hostas. They're not your normal color hostas, and most of these pictures were taken by me, but this was taken by a friend of mine who is a photographer. I love the way you can just see the drops of water on the hostas. What is this? People usually pretty quickly say a sunflower, and then some people catch that there's a bee on it. What is this? And usually the first thing people notice and what they say is butterfly. They might say butterfly on a flower. And sometimes I get someone tell me, as someone who tells me it's a tiger swallowtail butterfly. And yes, it is a tiger swallowtail butterfly. And those are butterfly bush or lantana in my yard as I'd work to attract those guys, quite honestly. I put out dill and fennel and everything that their caterpillars enjoy. What is this? Okay, it is another butterfly. It's on that same lantana bush. I think this is called Buckeye butterfly. I send my pictures to this little group, um, an entomology group that tells me my bugs. But it is a butterfly. What is this? Okay, and I usually get some kind of different answers here, and sometimes say, "Oh, it's a picture by you," and no, this is a picture by my brother. He's the artist in the family, and some people, most people notice it's trees, it's a forest. But I get different answers. I always think that the background kind of darkness, how there's like this shadow, is really interesting to me. And his work is, you kind of see different things in it sometimes. What is this? And I usually get answers of people. Sometimes I get answers of people dancing or some kind of get together, or people in a forest. Did they start talking about the trees? Okay, so what have we been doing? I've been by myself doing it. Usually I'm with a class. What have we been doing? And I usually get several different answers here, but I'm going to go ahead and just tell you we're recognizing objects, right? That is the beginning of this, is the idea that how how do we do this object recognition? What makes it easy? And again, my pauses are there for you to think about what makes that easy. Well, some people talk about the colors and things that pop off that are different colors so we can see them well, like the butterfly or maybe some of the clothes of the people really popped out, and so you could tell that was an individual object. Some people, and oftentimes the most common answer is something like, well, we've seen these things before. We've seen butterflies, we've seen flowers, we've seen forests and woods and so forth. What makes it hard? And usually here I get some kind of answer about how some of my brother's work is kind of ambiguous as to what you're really looking at. They're not clear distinctions like we usually get with objects. And I actually added his artwork after I taught this class a few times, maybe 2 or 3 times, where people would just think that I was crazy for asking the question, but I'm going to tell you. Actually, that's the point, kind of, is that it's incredible that we do this, and there are many challenges to how we do this job of object recognition, even though, as most of my examples showed, it seems very easy, very seamless. It doesn't take any effort to recognize objects, but that's really incredible given the challenges of object recognition. So one of the main challenges of object recognition is object constancy, that the percept of an object seems to be unchanged despite the image of an object changing significantly depending on various aspects. So our viewpoint, I'm showing here the rubber ducky from different perspectives and different viewpoints, and yet we can see it from the front, we can see it from the side, and even though none of us have ever seen this rubber ducky before, we all can recognize the rubber ducky as a rubber ducky from both of those viewing conditions, and not just both of those viewing conditions, but the one down at the bottom where the part of it is in shadow, right? So the lighting changes, different kinds of emitted light can change colors slightly, but we don't have this sense of color changing, but we can get lighter and darker and different kinds of lighting, and we still can recognize an object. We can have it be blurry, we can have it be occluded, in shadow, and so forth. So some examples of object constancy, that examples of an object from different viewpoints. If I asked you which 2 faces in the top example are the same faces, A and B or A and C, most of us very easily and quickly say A and C. And in fact, the fact that A and B are from the same viewpoint make it really clear that those are 2 different people. This is one of the problems with our facial recognition software at this point, that facial recognition would say A and B appear more similar because C is from a different viewpoint, and it's not giving the software the same information. And I think that they're getting much better at this, but for us to recognize a person, they need to look in a certain direction at the camera. And that's not true for people, for us. We can recognize someone from the side or from behind sometimes, depending on the viewpoint. Some examples of blurry objects. So here's another one where I get to ask people what they see. And I'm just going to go ahead and tell you that he changed the textbook. And this was actually the 8th edition. We're now in the 10th edition. And I now use the 10th edition. And I'm going to show those too. But just so you know how much harder this was, and how interestingly it's the societal, it's how much what's going on in society right now influences these abilities. And so it's that kind of that perceptual set and the top-down knowledge that's helping us so much. So from left to right, I'm just going to go ahead and tell you. I usually make you guys guess, but you're not here to guess. is Prince Charles, Woody Allen, Bill Clinton, Neil deGrasse Tyson. I'm blanking for a second. Hold on. Oh, Nixon. Richard Nixon was just all I can think is I'm not a crook. And then Princess Diana. And people can get some of those. But just because I thought it was interesting, again, how important top-down knowledge is, and so who we're actually seeing in the press and so forth. Now, this is the new set, and if I'm going to sit here quietly, you can figure all of those people out pretty easily, right? That one person I don't know. Well, so I know Will Smith. I think her name's Taylor Smith. I don't know her. Barack Obama, Hillary Clinton, Jackie Chan, Ben Affleck, and Oprah. And again, for some of us, some of those are going to be easier. I know Taylor Swift because he puts it in the textbook. I don't think I've ever seen her. I don't have TV or anything, so yeah, this is my only experience of Taylor Swift. Maybe once in a while I've seen her on an internet page, but most of you probably recognized her really easily. And it depends on our own experience, but even the point is that even blurry objects, if we have some experience with them, we can recognize those objects. Another major challenge to object recognition is the ambiguity of the image on the retina. Okay, so think about what we're looking at out in the world is three-dimensional space, and things are in different distances from our eyes, and yet what we get on the back of the retina, right, is an image on the retina that is a two-dimensional image, which causes the inverse projection problem. The fact that an image on the retina, if we kind of project that out into three-dimensional space, that can be caused by an infinite number of objects. So this is showing close up the rectangle, so a piece of paper that would be hitting the back of my eye as a rectangle. I can actually move that piece of paper farther and farther back, and if it's taking up the same amount of retinal space, it would be getting larger and larger, but it would be farther and farther away, and I would be perceiving that, right? I'd be perceiving that it is larger and it is farther away. That isn't really confusing to us. We can also take it at different angles where we make it more of like a trapezoid, and then we put some of it closer to us and some of it farther away, as these other pictures are showing, and that's going to hit our retina still as the same kind of a rectangle that's the same size as the piece of paper that's close up. So this is incredible. We don't experience this constant ambiguity. Every once in a while we might misinterpret something, but most of the time we have no awareness of this ambiguity. And this is one of the main reasons, I mean, other than I've spent some time talking about the superior colliculus, this is one of the main reasons why it is so difficult to create a perceiving machine. I mean, it's one thing, well, a perceiving moving machine, we need the eye movements, but a perceiving machine, most of the facial recognition software that we've created, it is still pretty confused by just me moving to a profile, from seeing me from a different viewing condition. We don't have that problem. And I included this picture just because I thought it was neat, and it is ambiguous. And this is an example of us misinterpreting, so I didn't look it up which school this is at, but it's an art school where if you're on the second floor balcony of a particular building, you see what's in A, and it looks like a circle, and that is making a circle on your retina. But if you go down to the ground and walk around it, you can see that it is this weird. It's not a circle. It's this weird shape that is created so that it makes that circle on your retina, so that it looks like a circle when you're standing in that particular spot. Artists use this kind of ambiguity quite a bit. Object learning is another challenge, that we can learn a brand new object in one viewing condition and then be able to recognize and identify it in another viewing condition. I usually have that rubber ducky up here still where we can learn it from face on, but you can spin it around and put it in the shadow and we can still identify and recognize it. But I changed my pictures here for categorization. You're able to recognize an object that you have never seen before. So we have this concept or this category of dog, and even though I went and just looked up rare dog breeds, and maybe the top right one is a little bit ambiguous because they're hard to see because of the background, but most of us can pretty easily tell, even though I've never seen this breed of dog before, I know those are all dogs, and they're pretty easy to recognize. There are always these instances that are kind of odd for the category, like the hairless cat and things that maybe take us a little bit longer, or we need to be told that a bat is a mammal. But for the most part, we can get a whole new instance of an object and figure out the category that it belongs to. I'm going to go through a number of theoretical approaches to object recognition for explaining how we do this, even though we have all these challenges. And I'm going to start with the recognition by components theory of Irving Biederman. Your author took it out of the book, but it's a really good time, I think, to go back to that idea of bottom-up versus top-down processing and think about how we explain our perception. So Irving Biederman has this very bottom-up approach to object recognition. He claimed that all objects can be described by a finite set of three-dimensional shapes, that these shapes are, he called them geons, that they are basically like geometric ions. So we can with ions, we can make up all kinds of, molecules and so forth. So he proposed 36 geons, suggesting that this was enough to enable us to mentally represent a large portion of the easily recognizable objects in the world. Okay, this is a lot like the old time feature. The way we used to talk about pattern recognition was how are we putting together these features, or do we have some kind of template? And this was really like those feature analysis theories of how we recognize letters and everything else. But this is in 3 dimensions, and so we have these 3-dimensional geons that are making up our objects. Okay, so there are a number of points that Biederman makes and a number of natural kinds of conclusions that we can get from recognition by components theory. But one of the points that he makes as part of this theory is that not all information is equal. And if there are certain aspects of an object that are obscured, it's more difficult for us to recognize the object. So he found that obscuring the meeting points was more costly. And if we look at the examples up on the left-hand side, I'm going to take the cup and the wine glass as examples, but you can kind of look down them and see what you feel like your own experience is. So you might want to pause this and actually say, which is easier for me to recognize as the cup, B or C? Okay, well, what he found was that B was always easier or on average, it was easier for participants than C. And what he was leaving, so he left the same amount of overall information intact, but what he was leaving in B were those meeting points, okay, where we have an intersection, and those are taken out in C. And you can see in the wine glass example as well that you get some sense of the wine glass in B, but as you get to C and those meeting points are taken out, it gets harder. When I look at that one really closely, it looks kind of like a smiley face with a weird hat on. Anyway, and then we also have these accidental viewpoints, okay, where we can see something from a different point of view, and we have lost some of those really important meeting points that are telling us what the object is. Okay, so sometimes these accidental viewpoints make it very difficult to recognize an object. And I think your author has it in there still, where you're looking at a tea kettle from the top, looking down at it, and it takes a little bit longer to recognize it that way than if you were to see a tea kettle as we normally do, as walking on kind of horizontally up to it. And these accidental viewpoints, part of what was going on here, as he said, was that we're not seeing some of what he called non-accidental properties, or NAPs, as he shortened it to. But those, so before, when we looked at the intersection, those intersections are important for us to be able to recognize an object. Okay, so he shows us the brick geon, and that some of our non-accidental properties are those lines, but also line 1, line 2, line 3, but also that kind of coming together at the corner there, which he called a Y. If you look at it, it kind of looks like a Y. And we have another intersection where the bottom corner comes together, and those are telling us that this is a three-dimensional brick. With the cylinder geon, similarly, we have the line 1, line 2, but we have this kind of narrow Y that is telling us, it actually looks like a circular Y to me, but it's telling us that this is circular. But line 1 and line 2, along with that intersection and that roundness, those are non-accidental properties that are telling me that this is a cylinder. And if we spun that around, okay, you kind of have to imagine spinning that brick geon around so that you see it from just one side. It might just look like a rectangle, or you might not really be able to tell what it is. And same with the cylinder. It might just look like a circle, or you're not really sure what it is, because you're not getting the information of those intersections. You're not getting the information from those non-accidental properties. At this point, I usually pick up a quarter and kind of show that there are many ways that I can spin this quarter that you can still see it. But if I spin it so you're looking at just the narrow little, you're looking at it as if you were looking at it from the side, and you don't get the circularness of it, it's harder to recognize as a circle. I'm sorry, as a quarter. So here's another piece of evidence for recognition by components theory. Biederman did a great deal of research that he found pretty good evidence that we are recognizing objects by these geons, by their small components. And as far as feature theories go, I thought the amount of evidence that he found was pretty incredible. That example before, where the meeting points are taken away versus the other parts of the picture are taken away and not the meeting points, participants were showing the results that he expected to see in that if you left the meeting points intact, it was easier to recognize the object. Well, he did another study here where he looked at different objects that had different numbers of geons. And I don't know, I've tried to count this before, but I'm not sure this little drawing or generalized view of an airplane is an example of an object, of one of his objects, but he had different numbers of geons, like 9 geons versus 6 geons. And then he would give people a certain number of those geons and ask them if they could recognize the object. And for the 9 geon objects, on average, if there were 3 geons given, people were at about 78% correct. 6 geons given, 96% correct. So the more geons we are given, the better we are at recognizing an object. And for a 6 geon object, so now if we have 3 geons given, we have about half of the geons, and people are at about 92% correct. Okay, but now I usually ask, what are some potential difficulties for recognition by components theory? And it is a green question, so I do want you to think about that, and then start the next lecture video and I'll come back to it, but I usually get really different kinds of answers from students. So what do you think?